All right, boys and girls, welcome back. Quick little 5-minute lesson today on parallel lines and transversals. You guys have seen this many times before. What's going to be new is using a two-column proof to prove some of these things to be true. So the diagram shows two parallel lines. Notice that these red arrows indicate that they're parallel. Okay, so that's a new little piece of notation. And they're cut by a transversal. A transversal is simply a line that intersects at least two other lines. Okay, so what relationships among the angle measures? Well, hopefully you remember that 4, 8, 7, and 2, no, sorry, 2, 4, 5, and 8, these are numbered weird, are all going to be congruent. So all the angles that are acute are congruent, and then 1, 3, 6, and 7, those are all going to be congruent. Okay, now 4 and 6, these are going to be supplementary. They add to be 180. Same with 3 and 5, same with 2 and 7, same with 2 and 3, same with 1 and 8. Okay, so when parallel lines are cut by a transversal, the resulting angles are either congruent, supplementary, or both. What situation would cause 1 and 2 to be both congruent and supplementary? Think about the answer. Okay, so we got a postulate and 3 theorems. The postulate, as it turns out, we're not going to prove. It's going to be assumed to be true. And then the theorems we're all going to be able to prove. So you want to make sure you take down these in your notes. These are going to be reasons that you can cite on your proofs to support statements. Okay, so you got same side interior are supplementary, alternate interior angles are congruent, corresponding angles are congruent, again, if the lines are parallel. And if the lines are parallel, then alternate exterior angles are congruent. So now we have more reasons that we can use in proofs. Let's take a look at a proof. So we're going to prove that alternate interior angles theorem. So if two lines are parallel, then angle 1 is congruent to angle 2. Notice they added an angle 3. When you do this, you should really think about the proof in your head or even write a flow chart out on your note page and then record your structured two-column proof. So I know that 1 and 3 are supplementary. That's from the same side interiors postulate. I also know that 2 and 3 are complementary, and that's from the linear pairs postulate, okay, or the definition of supplementary angles. So if two angles are both supplementary to the same angle, then they must be congruent to each other. That's the definition. Well, so that's kind of like my thought process. That's how I think we're going to do this. And now here, look, this plan is kind of talking you through what I just said. So now let's look at the proof. M is parallel to N. That's given. 1 and 3 are supplementary. We know that from the same side interior postulate. Okay, what does that mean? Well, 1 plus 3 is 180. That's the definition of supplementary. Well, 2 plus 3 is 180. Um, let's see, because they form a straight line. So now, since 1 plus 3 is equal to 180 and 2 plus 3 is equal to 180, we can say that 1 plus 3 equals 2 plus 3 by transitive. They're both equal to the same thing. Well, both of these things contain an angle 3. So if we subtract an angle 3 from both of them, we get angle 1 is congruent to angle 2. And if you just ended it with 6, I would be totally fine with that. But there is a difference between the measures being equal and the angles being congruent. But you don't really need to understand that difference right now. In fact, if you never did, it wouldn't bother me that much. There is an example of proving one of these theorems congruent. Boom.